In this video, we're going to talk about how to graph y equals sine of bx and y equals cosine of bx. So what does that mean? It means we're going to take our functions, sine and cosine, and we're going to change the period so that it's no longer 2 pi. The sine and cosine functions both have a period of 2 pi, which means that's how often their wave repeats. That's how long it takes for the wave to repeat. So I went ahead and I graphed just the parent function of sine and the parent function of cosine. I just re-emphasized that our period was 2. And I put down here for you all of the points that I have graphed. Now, the main thing about changing the period is to understand that you can notice that all these points are equal spacing away. So they're each 3 grids away from each other. In this case, my scaling on my x-axis, I counted by pi over 6. However, you just notice that they're 3 away, 3, 3, 3, because each point that we're graphing for our sine and our cosine functions are equally spaced. And so that's an important thing to know when we're going to change the period, so that we don't have to figure out each individual point. We just have to kind of figure out what's the end mark, and then we can figure out where my points are going to be in between. So what we have to do is when you have this b value, okay, so this b value looks like this. So it's y equals, we'll just pick sine, some number here, which we call b, times x. This number right here is the b value, and that's going to change the period of your function, which will change if it will either like shrink it down, and it will either make it so your sine function might look like this, okay, or it can make it really wide so that your sine function will look like that. And it can do the same with cosine. It can make it really small, or it can make it really kind of wide like this. So that's what that b value is going to do. It's going to change how often or how long it takes for the function to repeat itself. So let's talk about how to find this. So to find the new period, we take 2 pi and we divide it by our b value. Okay, and that will tell us what our new period is and where our function is going to stop. Now, when we're drawing these graphs, we only need to draw one period. So I'll kind of show you how to do this. And note that my scale here is also pi over 6, but you'll notice that I didn't mark pi over 2 and 3 pi over 2. I just only marked pi's, okay? And it's the same on all my graphs. And the reason I did it that way is because it is the main points and while we count by on the unit circle. So that's the easiest way to, get the values that we're trying to find. Okay, so example number 1, we want to graph y equals the cosine of 2x. So first thing I have to do is I have to find my period. Okay, so my period is I take my 2 pi and I divide it by my b value. My b value is this guy right here, so this value 2 is going to go here. So 2 pi divided by 2 is equal to pi. Okay, so that means that instead of my period being 2 pi, my cosine function has to squeeze into all the way up to this point. So I'm kind of taking my function, my regular function, and I'm squishing it in. Okay, so it's going to go there. All right, so here's what I have to remember. My cosine function starts up. So when I say start up, I just mean it starts at the 1. So my starting value doesn't change. Okay, and I have to graph, you can count. We have 1, 2, 3, 4, 5 points I have to graph. So the easiest thing that I like to do, we'll notice this point right here is smack dab in the middle. So I kind of halve the values that I have. I take it in half and then half on either side. So I come down here and halfway in is, and remember cosine, it starts up so it also ends up. So my point is going to start here and end here. Halfway in, we are down, and then half of this, 1, 2 is in the middle, and 1, 2 is in the middle like this. So my graph is going to look like that. And then you'll notice that I'm going to zoom this in so that you can kind of see that my distance, this is like 1.5, and this is 1.5, and this is 1.5, and this is 1.5. They're all the same amount of distance, and that's going to be what my graph is going to look like for y equals 2x. All right, let's try the next one. Y equals y equals the sine of 2/3 x. So again, I have to find my period. Equals 2 pi divided by b, and my b in this case is 2/3. Okay, so I don't want to have to deal with a fraction and a fraction, so I'm going to multiply the top and the bottom by 3/2. So this becomes 2 pi times 3/2. My 2's cancel out, and I'm left with 3 pi. Okay, so now I'm taking my sine function. Normally it ends here, and I'm kind of stretching it out, so it's going to end here. All right, so the sine function starts at the 0. So I'm going to plot my point here, and then there's 3 zeros if you look up here. So I have 1, 2, 3 spots where it's 0. I have one that's positive and one that's -1. So I'm going to go down here. I'm going to find halfway in between. So halfway in between 1 and 3 is 1.5. So that's going to be halfway here. Okay, then I have to find my distance. So I'm counting 1, 2, 3, 4, 5, 6, 7, 8. So I count 4 in, 2, 3, 4, and I'm doing my sine graph. So sine starts up, and then 1, 2, 3, 4 goes down. So this graph looks like this, and you'll see it's kind of stretched out. Okay, remember that your amplitude, this value right here, didn't change, because that would be that number out here in front. Okay, last one. So I got cosine of 3/2x. So I'm going to find my period. I take 2 pi divided by b, which is 3/2. Okay, and I'm going to multiply so I don't have to deal with a fraction in a fraction, times 2/3 times 2/3. So I get 2 pi times 2/3 gives me 4 pi over 3. Okay, so 4 pi over 3. Remember, I told you that I was scaling. Each one of these was pi over 6. So if I'm counting by pi over 6, I'm actually going to take 4 pi over 3, and I'm going to multiply it by 2 on the top and 2 on the bottom, so I can have a 6 in the denominator. So I end up with 8 pi over 6. So what I can do is I can actually count 1, 2, 3, 4, 5. So this is 6 pi over 6, 7 pi over 6, 8 pi over 6. I'm going to do that one more time. So this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. So right here, I'm taking my graph and I'm squishing it in. Okay, so we're graphing cosine. Cosine is an up function. So at this point, I'm going to have my value up here and my value up here. Remember, my starting point doesn't change. Okay, then I have to count halfway in. So if you'll notice, I'm at 1, 2, 3, 4, 5, 6, 7, 8. So I have to count halfway in, which is 4. 2, 3, 4, and that's where I'm down. And then I have 2 over to the right and 2 over to the left. So now my graph, oh, that's kind of a bad graph, looks like. Sorry. Looks like that. Okay, so let me know if you have any questions. And when you're graphing, watch out for how you are counting in your x-axis. Most of the time they do count by pi over 6, but sometimes they do count by pi over 4. So watch out if the graph is already pre-drawn for you so that you make sure that you're putting it on the correct mark. If you have any other questions, let me know. Good luck.